Okay, so we are getting ready to review for our first test of the year, and this is the Unit A test. So we have the review packet here. This is the key, and we're going to go through the answers. So the first one here, we have this little picture off to the right, and we have the first question is name a line that contains point A. So point A is right there. So you can see it's this line here. Now we have a couple of answers here. This is this lowercase letter L. So we could say this is line L. Or we can say that this is line AC. Or we can say this is line BC, or BA or CA. So there are three possible answers for this. So as long as one of these makes sense, that's fine. Remember the lowercase letter here, that could show that this is this line. But we don't always use that, so we mostly use these points. So 2 points here make the line, so that's what we get. We can see that here for this line. What's another line? What's another name for line M? Well, there's line M, and we can see that's made up of these 2 points, B and D. So for number 2, the only answer is line BD. We could say line DB, and that's perfectly acceptable. But make sure we write that. If we have line AC, and we want to write a point not on AC, we can see that line AC is this line here. Point B is on that. So we could say that point D is not on line AC, or point E. Notice I don't say point, I say it, I don't write it. So I don't write point D or point E, I just D or E. And you don't have to put both, just one or the other. And don't write the word point. We understand this to be a point, and that's why we put the little line symbol so we know it's a line. All right, name the intersection of AC and DB. We see AC is there, DB is there. They intersect at point B, so the intersection is a point B. So name a point not on line L or line M. So this is line L. This is line M, and we can see the only point left out is E, which is floating all the way outside, so point E. All right, we have this picture now, and it's kind of weird, but remember this dotted line means that it goes through, so it's behind. So if this is a flat surface, this dotted line is actually behind this plane. So if I were actually looking at this plane head on, so it were flat like a piece of paper, AE would go just like this. So we can see that that line AE is actually not on the plane, it intersects the plane. And so for this first question, we have name a line not contained on plane N. That would be line AE. Name a plane that contains point B. So it's asking for a plane, not a line, and that would be this. So it's that fancy N, which, wow, that's horrible. It's just a fancy N, so make sure that you write a fancy N however you want to do that, but it's just right there. That's the plane. And then name 3 collinear points. So number of people in the quiz did 3 pairs of collinear points. I want 3 points that are collinear. And there are actually only 3 possibilities here. It's going to be A, B, and E. So A, B, and E. All right, now we get into writing equations of lines. So slope-intercept form is y is equal to mx plus b. And here they give us a slope and an intercept, so that's easy enough. This is the b value and this is the m value. So y is equal to negative 4/9 x plus 2. Done. That's the answer. But number 13, they give me a point and a slope. So I'm going to have to use point-slope form. So that's y minus y1 is equal to m times x minus x1. And so we do y minus a negative 3 is equal to 3 times x minus 2. This is y plus 3 is equal to 3x minus 6. If I subtract 3 from both sides, I need to be careful. It's a negative 6 minus 3. So I get 3x minus 9. And that's my answer for number 13. So always use point-slope form unless they actually give you the y-intercept form. Point-slope form is easy, it's simple, and once you isolate the y, you just stumble upon slope-intercept form. Two more here. So they give us 2 points for both of these. So we don't have a slope, so we need to find that first. So m is equal to y2 minus y1 over x2 minus x1. And so we can take these points. So that's 8 minus a negative 4 over 5 minus 2. So that's 12 over 3, which is actually 4. So continuing on with this, I can see that I'm going to have, actually let me continue this down here. So I'm going to have 16. So y minus y1 is equal to m times x minus x1. So I could take any point. I'm actually going to choose this second point because I don't have any negatives, so I don't have to worry about that confusion. So y minus 8 is equal to 4 times x minus 5. And so I get y minus 8 is equal to 4x minus 20. If I add that 8 to both sides, I get y is equal to 4x minus 12. For number 17, I'm going to again need to find the slope. So that is the change in y, so y2 minus y1 over x2 minus x1. And so this is 2 minus a negative 1 over negative 4 minus 8, which gives me 3 over negative 12, which is negative 1/4. Hey, look, numbers 16 and 17 are perpendicular lines. And so taking the slope, so for number 17, I do point-slope form, y minus y1 is equal to m times x minus x1. I can take any point, so why don't I choose the first point this time? So y minus 2 is equal to negative 1/4 x minus a negative, so plus 4. So I get y minus 2 is equal to negative 1/4 x minus 1. And then if I add 2 to both sides, I get y is equal to negative 1/4 x plus 1. So that's those, and kind of ran out of space there. Should have spaced this out a little bit better. For number 1 here, in this section, we're looking for slope-intercept form again. So y is equal to mx plus b. And what we need to do is we need to find the point and the slope. Now it tells us that this goes through the point 2, 6, and it's parallel to this line. So we ignore the y-intercept and we just look at the slope. The slope of this line is 5, so any parallel line is going to have that same exact slope. So we have y minus y1 is equal to m times x minus x1. And so if I plug in my points, I get y minus 6 is equal to 5 times x minus 2. Distribute that in, so I get y minus 6 is equal to 5x minus 10. Add 6 to both sides, which turns out to be y is equal to 5x minus 4. And that is my completed answer. Let's do a different color here. So for number 2, it's a little bit different because here this is perpendicular. So m, the slope, is going to be the opposite reciprocal. This slope is positive, so that means this one's going to be negative, and we're going to have this to be negative 5/4. So if I do y minus y1 is equal to m times x minus x1, do y minus 4 is equal to negative 5/4 x minus 4. Distribute this in, so I get y minus 4 is equal to negative 5/4 x. Negative times a negative is a positive. The 4's cancel out, so I get 5. And then when I add 4 to both sides, I get y is equal to negative 5/4 x plus 9. So that's my answer there. So I have these different questions there. So make sure that you are just taking the slopes from the parallel line, the perpendicular lines, not the y-intercept. For this second one here, you can see it happened to be the same y-intercept, but that's not always the case. So make sure you use point slope, point slope, point slope, point slope, no point slope form. Here we want to multiply these out. So like I said before, we can take each term and multiply it by the whole parenthesis. So 8k times 6k minus 5 plus 7 times 6k minus 5. And so if we distribute this in, we're going to get 48k squared minus 40k plus 42k minus 35. Combine my two middle terms, and I get 48k squared plus 2k minus 35. We don't want to factor this because that would undo what we did, and we'd actually get this answer. So I leave my answer as that. And same thing with number 2. We want to take each term in the first parenthesis and multiply it by the second parenthesis. So 4x times 8x plus 2 times 8x plus 2. So I get 32x squared plus 8x plus 16x plus 4. Combine the two middle terms. So 32x squared plus 24x plus 4. Don't factor out anything. Right, so hopefully that's straightforward. And again, I don't care how you multiply. If you want to use that FOIL method, so be it. But yeah, however you want to do it, as long as you're getting the correct answer. Now for these, we get a little bit of an issue because we get some fractions. So what we want to do is we just want to straight multiply out. And so I'm going to set this up so that I have 25 over 7p times 29 over 7p minus 1 over 7 plus 5/4 times 29 over 7p minus 1/7. Distribute this in. So if I have 25 times 29, that's going to be 725. So 725 over 49 p squared. Distribute this in, I'm going to have minus 25 over 49p. Here there are no common factors again, so I have 5 times 29, which is 145. So 145 over 28p. And this is not a nice one. Minus 5 over 28. So here, greatest common factor between 49 and 28. If I just multiply them together, I get a really big number. But this is actually 7 times 7, and this is 7 times 4. So I could probably find another factor of 7 that they both go into. But you know what? For the sake of what everybody probably did, I'll just multiply them together. So here, if I multiply this by 28 over 28, so 49 times 28, again, that is going to be 1372p. 25 times that 28 for that common denominator is going to be 700. and I'm going to add this to the same denominator. So that 28 times 49. Here I'm multiplying this fraction by 49 over 49. So 49 times that 145 is a big number, 7,105. That's 5 over 28. And here we're just going to combine these two. So we have a negative 700 plus a 7105. And that's just going to give us 6405 over 1372p. 725 over 49p squared. This is going to be a positive because this is a lot bigger than this. Minus 5 over 28. So this one has some ugly fractions, but some really good practice. And you'll definitely have this on the test, but certainly not this scary numbers. All right, if we look at number 4, we want to have the same setup. So 11 over 8k times 15 over 4k. Sorry, I was just checking out that last problem. Yep, that looks good. 15 over 4k plus 3 over 2 minus 11 over 7 times 15 over 4k plus 3 over 2. Right, so we distribute this in. We don't have any common factors, it looks like, so it's a little bit of a letdown, so we're going to have to do this crazy multiplication again. So 11 times 15 is going to be 165. 8 times 4 is 32, k squared. Again, no common factors, so we get 33 over 16, and that's a k. Here, no common factors, so 11 times 15 is yet again, that's going to be a negative 165 over 28k. This is a negative times a positive, which is going to be a negative 33 over 14. So we want to combine these two. And so we can just find a common factor. So 28 times 2 is 56, which 16 does not go into. 56 times 2, that was 112. So actually the common denominator here would be 112. So why don't we do that method this time? So here, if I have my common denominator, it's 112. So plus 112k minus 112k. What do I need to multiply 28 by to get 112? Well, 4. So what's 165 times 4? And that's 660. And then over here, what do I need to multiply 128? Or sorry, what do I need to multiply 16 by to get 128? 8. So I do 33 times 8, which is 264. And so now I have 264 minus 660 in my numerators. So that's going to be a minus 396 over 112k for 165, 32k squared minus 33 over 14. And I know I make a big stink about simplifying your fractions, but for this, we've done enough work. This is fine. You can totally leave your answer like this. I'm not too concerned about that. So with this, it's a lot of work, but I want to make sure you can work with fractions. It's going to be very, very, very important for later on, for Algebra 2, for pre-calculus, that you can work with fractions. So while these numbers right now, you may not pay much attention to, when we start throwing binomials and variables into these fractions, you're gonna be very thankful you can do this sort of operation. But again, make sure that you know how to multiply out these binomials too. All right, now we just want to factor these, and I think that's pretty much going to be it. Yeah, so we want to solve these by factoring. So if I look here for this first one, this is hopefully simple enough. 2 factors of x squared are just x and x, and 2 factors of 12 that combine to get a positive x, positive 4, and a negative 3. So I set these two factors equal to 0, x plus 4 equals 0, and x minus 3 equals 0. And I get x is equal to 4, and x is equal to 3. Sorry, that's a negative 4. So I write my answer as negative 4, 0, and 3, 0, because these are the x-intercepts. Here, this is already factored. So, I mean, you could multiply it out, but you're just going to have to factor it again. So I set these two factors equal to 0. So I get x is equal to 6/7, and x is equal to 3. So I get 6 over 7, 0, and 3, 0. Number 7, we want to factor this. We can factor this any old way we want. So why don't I use the AC method? That's a nice one. So here, A times C is 160. So we need two factors of 160 that combine to get this 27. So if I do 1 and 160, 2 and 80, 3 and nothing, 4 and 40, 5 and, oh, what would that be? Something 22? 5 times 22 is 110. It's been a long day. So 32. And look at that. That's it. We can say that because here, that symbol means that these are going to be opposites. So I'm going to have 1 plus and 1 minus. And this sign means the larger one will be 32. Will be a positive. So it'll be the 5x. So 27 is really 32x minus 5x. So 4x squared is 40 equals 0. And I can group these and factor these. Now be very, very careful with this. Notice how I'm going to do this. I'm going to have 4x squared plus 32x. And then I'm going to have plus negative 5x minus 40 equals 0. Notice I did not put a minus sign between these two parentheses. That's going to change everything inside. So if you just here, don't just put parentheses. Make this a plus and include this negative sign inside the parentheses. So when I factor out my greatest common factor here, I get 4x, and that leaves me with x plus 8. Here, now I can factor out a negative, so I can do a negative 5, and that leaves me with another x plus 8. So my answer is 4x minus 5 times x plus 8 equals 0. Set these respective factors equal to 0. And so I'm going to get x is equal to 5/4, x is equal to negative 8. And just continuing down, if I want to write these as x-intercepts, I'm going to get 5/4, 0, and negative 8, 0. All right, and the last one is going to be, well, we can do that AC method again. So there's no common factor here. Always look for that common factor first. But here, I'm going to have 7 times 25, which is 175. 75. Change that. They're going to be 30 apart. This means that they're going to be one positive, one negative, and this negative means that the larger one will be negative. So 1 and 175, 2 and nothing. 175 is not divisible by 3. It is not divisible by 4. It is divisible by 5. So 5 and 35. Oh, there we go. They're 30 apart from each other. So again, I'm going to make the larger one 35x, the smaller one 5x, and negative 35x plus 5x is negative 30. 7x squared. And again, however you factor these, it's okay. This is just the AC method. Not particular about the method. Here, if I factor out the greatest common factor, which is an x, I get 7x plus 5. And for these, the greatest common factor would be a minus 5, so minus 5. And I'm left with a 7x plus 5 equals 0. So I get 7x plus 5 times x minus 5 is equal to 0. I get 7x plus 5 equals 0. x minus 5 is equal to 0. So x is equal to negative 5/7. X is equal to 5. And so I get negative 5/7, 0, and 5, 0 as my x-intercepts. So that's what we need to do. So a lot of algebra in this test. This is mostly algebra stuff, factoring, multiplying binomials, equations of lines. The only real new geometry stuff is going to be this portion on the test. So make sure you review this. You've hopefully seen this before in algebra, but definitely go through this. If you can do any of these questions, you can do anything on the test. Feel free to ask me any questions about this, how to do any of this. Anything you don't understand, make sure you ask about before we get to the test. All right, well, good luck.